Hey everyone, I just wanted to do a additional example of a problem from 5.4, one that might be a little different than what was in the notes packet. So this one's number 13. It's talking about a machine used to fill gallon-sized paint cans, and so that the amount of paint dispensed has a mean of 131. So that mean is the population mean mu. So mu is 131. And then the population standard deviation sigma is 0.3. You randomly select 35 cans. That's an N, that's a sample size. So N is 35. And the sample mean of cans is 130.9. That's an X bar. Sample mean X bar. Okay. Does the machine need to be reset? And then explain your reasoning. The idea for this one is to find the z-score. And then that's all you'll really need. So, and then we'll interpret the z-score to fill out these blanks. But let's find that z-score. And so I'm going to go to my whiteboard and work this problem out. And I kind of already got it started here. So again, we have mu 131, sigma 0.3, and 35, and x bar 130.9. It's easy to get mu and x bar mixed up because they're both means. Just remember the x bar comes from the sample of the 35, the mean of those 35, whereas the mu is the overall population mean. So it's kind of an interpretation reading the problem to get those right. And then when you do the z-score, there's your formula that we developed in section 5.4. So if I plug those numbers in, I got the 130.9 for x bar, the 131 for the mu, and then sigma divided by square root of n in the bottom. And then I like to type this all at once into my calculator using those parentheses, kind of just typing it in just like it looks there. So you can try that too if you want, just to make sure you're getting it right in your calculator. Okay, so this one for me ends up being about negative 1.97. Okay, now what does that mean? Okay, so that's a z-score that gives you the number of standard deviations, in this case below the mean, in the sampling distribution. Now, the marker we're using is 2 standard deviations, so anything outside of 2 standard deviations is unusual. So this one's close, but it just misses. It's within 2 standard deviations, so it's not unusual. Okay. So let's go back to the problem and see if we can make that interpretation. So we know that that sample mean is not unusual. Okay. So that means then that the machine itself is doing a pretty good job. Like if we got something that was kind of unusual here for that sample mean, then probably means this machine is not being, or it's not doing a very good job of dispensing that mean of 131, right? But this one, does the machine need to be reset? I would say no. If I got something larger than 2, I would say yes. Right. It's kind of likely that you would have a random sample of 35 cans with a mean of 130.9, right? Because we got less than 2. If we got more than 2, it would be unlikely or unusual to see this, right? But it lies within the range of usual events, namely 2 standard deviations. So it's lying within those 2 standard deviations. Okay, so let's check to make sure that that's right. Whew. Okay, so that one works. So it takes a little bit of thought to kind of figure out the logic of those. But basically, if you get something less than 2 standard deviations or within -2 and 2, it's a no. And then outside of 2 would be a yes. And then everything else kind of follows after that. Okay, so hopefully that one helps a little bit with 5.4. If you have any other questions, send them my way. Okay, hope all's going well with you out there. I'll talk to you soon. Bye.